Good morning, everybody. Thank you so much to Doug and to the CIMAR team for putting this all together and having us here. While he's pulling up the slides, I'll just do my quick introduction. So we've had a monumental effort to do climate downscaling at very fine resolutions for the main Hawaiian Islands to look at 3 different climate scenarios. And I'm gonna present very briefly today some sort of important results of how these different climate scenarios impact both the coastal, that being coral ecosystems, and pelagic ecosystems around the main Hawaiian Islands. So this is a large effort with a number of people here on the top row from my lab, collaborators from UH and from NOAA. Everybody has contributed to this, so I'm just up here to kind of give you a quick overview. I will highlight a number of posters that you can see today for more information on each of these things. So let's talk quickly about Hawaii. It's very unique in the Pacific. Despite our minuscule size within the Pacific, we have a majorly outsized influence on climate around Hawaii. As massive mountains, we disrupt the ocean and the atmospheric flow, as shown in this seminal paper by Peng back in 2001. These wakes behind the island extend thousands of kilometers across the Pacific. So it's very important to understand these things if we want to understand climate. But in the global climate models, what is it that we see? Of course, we don't see this because they don't resolve it, but what are the 2 major impacts that are coming to Hawaii? Here we see an animation. We're stuck in between a rock and a hard place. We have an expansion of low pH-like conditions from the north and an expansion of equatorial heat conditions from the south, right? These are the 2 major factors that are coming towards Hawaii. As you can see here, temperature arrives first, pH a little bit later, but these are the major factors we're interested in. So if we take a look at around the main Hawaiian Islands, what we see on the left is what the global climate models tell us. And again, they don't even have Hawaii. There's one little rectangle there for the island of Hawaii. The rest is open ocean. It's very deep. They don't even recognize the seamounts. So we have very limited dynamics that are not resolved whatsoever. So we've downscaled that at very fine resolution to capture all of the very important dynamics, the wake, et cetera, around the main Hawaiian Islands. And one thing I want to point out is that if you look at on the right, on the main Hawaiian Islands, you can see very strong spatial variability across the islands. One side of the island can be very different than the other. This is not something you get from global climate models, and this is important if we're interested in things like refugia and what we might be able to do to mitigate some of these effects. So let's first look at the coral ecosystems. Here we see some work from Kate Falloy. This is the temperature record of the corals all around the main Hawaiian Islands as projected in 3 scenarios, SSP1, which is, I call it akin to the Paris Accord, SSP2, which is business as usual, and SSP3 is the realistic worst case scenario. We'll ignore fiction of SSP5. And so what you see is kind of what Chip was talking about. We are on a trajectory. It doesn't matter the emissions right now. We have a momentum. You see in temperature, we don't even start to separate until maybe 2060. By the way, this is 2-year low pass filtered because the annual cycle's crazy. So what we can see is that by the end of the century, though, we do see a separation in these different climate scenarios. This is ocean temperatures, not air temperatures, but we see a roughly 3-degree increase in ocean temperature in the worst case scenario. But what does this mean in terms of the corals? Well, one way that people like to look at it is degree heating weeks. And so you see SSP 1, 2, and 3 in the degree heating weeks. All 3 scenarios are in severe or extreme degree heating weeks by the end of the century. However, corals are living organisms. And based on work that Rob Toonen has done, his group has done at HIMB, they've shown that many of the corals around Hawaii have around a 2-degree per century adaptation rate. So if you look at the dashed line in each of these scenarios, you can actually see that if that were included in SSP 1 and 2, there would be no degree heating weeks of severe impact to the corals by the end of the century. It's different in SSP3. But what if we look at that spatially? here I'm showing the SSP3, the worst case, but what we can see is very strong spatial variability around the islands, where some locations are more shielded from these effects than others, okay? And we'll keep this in mind. Of course, as temperature is expanding from south to north, it's worse on the Big Island and best on Kauai. However, these corals cannot adapt if other things are happening, right? If you have the flu, you're less able to deal with other things that are going on, right? And so the other impacts that we worry about are ocean acidification. And here we see work by Lucia Hosakova. She has a poster today that you can look at. And again, looking at the corals, I'll just show today for aragonite saturation. But we see in the top a very stark difference as opposed to temperature, a very stark difference in terms of the different scenarios. So on the upper panel, the teal, the line that doesn't change so much as SSP1, then SSP2, and SSP3, right? We do not want aragonite saturation to get too low. Corals can no longer form and potentially move into dissolution. Of course, every species is a bit different in terms of their sensitivity to the saturation. So one way that Lucia has devised to look at this is what we call novelty. And so here we can see that the number is essentially how different are conditions from today. And if you look at SSP1, in fact, conditions will remain very similar to today. SSP3, unfortunately, they're roughly 12 times different than today, which you can kind of think of as like 12 standard deviations away from what it is today, right? So unsustainable for the corals. But once again, we see a strong spatial variability in the aragonite saturation novelty here, but whether we look at the novelty or saturation. But the point being is that there are regions of refugia where variability can be much greater, where the corals are more resilient, and places that we can identify where we can address adaptation if we can get the world to work towards newer scenarios. Okay, and you can see Lucia's poster there highlighted. Now, taking all of that, Lansing Peng, who works with Kirsten Olesen here at UH, took our results and ran an Atlantis ecosystem model for the coral ecosystems. And I will just quickly highlight her results. Again, she has a wonderful poster here today. And we can see, just look at the bottom, I guess, a dramatic increase. This is for SSP3, worst case scenario. We can see a dramatic increase in both the algal cover around the islands, but again, strong spatial variability, and unfortunately, a very strong decrease in coral populations. But what about the pelagic fisheries? So here we see just sort of a view of where the fishing takes place, targeting big-eye tuna. These are deep-set, long-line fisheries. They also accidentally catch striped marlin, but we'll just focus on big-eye tuna. So this is a large fish. It has autonomy, but its vertical environment is getting squeezed, right? We have, it's bounded at the bottom by low oxygen and bounded at top by high temperatures. So what's happening with that? So if we look in the southwest there, we can look at our realizations. This is again just for SSP3, but you can see a stark increase of more than 100 meters of the oxygen minimum zone, right? So it's squeezing their ability to dive deeper. And most of the fishing is done around 400 meters or so. You can see a big change in the amount of oxygen available at the end of the century. Tobias Friedrich has been looking at compound events for this region. So here we see an animation that shows where we have a compound event, wherever it's colored. And there are three different kinds of events. There's low oxygen, high temperature, and low pH. And so you can tell by these colors what kinds of events would be affecting, the fish that are trying to swim down there, or they would avoid this region. So again, and here this is for the 2070s, to give you a sense of what kinds of compound events happen around the islands. And again, you can see his poster today. Lastly, I just want to highlight some work that Phoebe Woodworth-Jeffcoats at NOAA PIFS has done. So she took the results from the global climate model in that northeast fishery, kind of more in the Bissell Ocean, and looked at how the impacts, what the change in the climate, how it would impact the fisheries themselves. So here I showed the big-eye tuna and the striped marlin. And the combined effect of present-day fishing pressures, as well as the temperatures, would not actually lead to a big change in abundance, but it leads to a major change in the population. No longer would there be sort of fully grown adults. It would just have juveniles. They would never be allowed to grow fully. They would be caught. Okay, so there's the quick takeaways. Of course, things, look dire in the worst case scenario, but we live in an age, unfortunately, in Europe and the US, the countries that are, creating these issues that Chip just talked about. We live in an age of nihilism. Trumpism is not just the US, right? Europe is ravaged by it as well. So I like to say, look, SSP3 is bad, but let's focus on, say, SSP doing better than SSP2, because that gives us hope, right? The only message we can give is hope. We can just give in to nihilism and all drive, big cars, or we can have some hope. So in the future, we've just been funded by NOAA as part of the CEFI project that Ryan is going to talk about following this. And I also want to highlight another poster here by Dax Matthews. So we're expanding from the main Hawaiian Islands to look at the entire Hawaiian archipelago. And Dax is building up that model grid now, and he has a poster on that. So I'll stop there.